Hello friends, in today's lecture we are going to learn the internal functional block diagram of 8085 microprocessor. So as we learn the generic microprocessor block diagram, here you clearly seen same block over here. The first block is ALU, then another is register and third one is control unit. Just here that 8085 block functional block diagram shows detailing of how that parts are working or how they are get connected. So coming towards first block, that is ALU. ALU of 8085 is 8-bit ALU which is connected with different resistors surrounded by it. So ALU is the middle part which is connected with accumulator, temporal resistor and flag resistor. Also connected with 8-bit internal data bus and address buses. Now this ALU consists of adder, shifter and complementer. So it can perform 8-bit addition, it can perform ANDing, ORing or XORing and shifting 1 bit of data towards right or towards left. So by using this we can perform addition and subtraction instructions as well as logical instructions. The second part of 8085, which is resistor part. So you see number of resistors over here. The most important resistor is accumulator, because whatever data we want to process is first bring into accumulator and then it is passed to the ALU. So ALU is accumulator is an important resistor. Why? Because before and after execution of an instruction, data is present in accumulator. So accumulator of 8085 is 8-bit. Then next we are going towards temporary resistor. So here two types of temporary resistor you are seeing, one very near to accumulator and other on the right hand side list of resistors. So this temporary resistor hold data temporarily during execution of certain instructions like internal carries or internal borrow, etc. Then you find the list of resistors on the right hand side named as WZ, BC, D, HL. So these are general purpose resistors. WZ is the resistors used as a temporary resistor, while B, C, D, E, H and L, 6 resistors which are 8-bit individually used to store 8-bit data or can be used in a pair BC, D or HL. So they are draw like that, BC together, D together and HL together as a 16-bit to store 16-bit data or to store address memory location. So these are general purpose resistor array. Then we have 3 special purpose resistor. One is stack pointer, other is program counter and third one is incrementer decrementer. Each resistor is 16-bit. The function of stack pointer is to store the address of stack top. The function of program counter is to store the address of next instruction to be executed, and function of incrementer decrementer is related to memory address latch, that is memory incrementation or decrementation. Then we see another resistor called as instruction register, which is very important resistor because the opcode of instruction is stored in instruction register, which is then passed to a decoder and machine cycle encoder, which is connected with control section from which that instruction is actually executed. The last but not least resistor in this series is flag register. So you see here above arithmetic logic unit there is a flag flip-flops. So we seen that detail flag register afterwards, because there is a 3 marks question carried on this topic, flag register. Very important topic. So in the next lecture we are concentrating on flag register. Then the next part is timing and control section after seeing ALU, resistors and now third timing and control. So here clearly seen different pins connected with this timing and control section. The first is clock X1, X2, which is used to input the clock cycle to the control section so that it will create control signals using this clock and pass it over the different blocks of the 8085. Second is clock out, which takes the output clock frequency. Then ready, RD bar, WR bar. These are different controls that we learn in pinout of 8085. ALE, S0, S1, IO/M bar. You remember it. So different controls that connected with this timing and control section, and the main function of this part is that it provides control signal. So you find single lines are drawn on every block of this 8085 functional block diagram. See this, that control lines pass through accumulator, temper resistor, ALU, flag resistor, also to the general purpose resistors, instruction decoder, instruction encoder. So everywhere we are passing this control signal. So there are, you are finding two control signals in the upward direction. One is interrupt control, which consists of different interrupt pins: trap, RST 7.5, RST 6.5, RST 5.5, INTA bar and INTR related to interrupt. And another is serial input output control carrying SID and SOD lines. So this is the functional block diagram. The important question asked on this is that draw the functional block diagram of 8085 or explain different blocks of 8085. Many times only about the resistor, question is asked about the resistor for 3 marks. What are different resistors used in 8085? So prepare your notes related to these questions. Thank you.